Yeah. So this.
Okay, good morning, my dear students. We're going to start the class here. See, I think in the last class we just discussed two important parameter changes that affects over the optimum solutions. Okay, so one is on the cost coefficient. Second one is on the coefficients of the constraints also. Okay. In today's class, let us move on to the last parameter change. That is when we add the new constraint. So how that will changes the optimum solution. That we will go to discuss it now. Okay. So please make a note of these things in your book or a paper. Okay. So I think you can see this paper, this slide over here. Would you able to see everybody?
Yes, sir.
Okay, yeah.
Yes, sir.
So this is the last parameter change that we will going to discuss is the addition of constraints. See, in the problem what we were discussing, we have only the two constraints we were talking about. So when we add another one constraint to the existing constraints, so what will be the effect of that over the optimum solution? This is one of the most important the post optimality analysis what we do. So for an existing constraints, if we add another one constraint, so how the solution will going to get modified, or it requires any modification, or it remains same. So that is the case what we are going to discuss in today's class. Okay. So please make a note of that. This is point number 5, where we have addition of constraints. Right. Let us discuss that. Suppose that we have solved every problem with m constraints and obtain the optimal solution. We want to examine the effect of adding some more inequality constraints to the original optimum solution. Okay, so for this, we evaluate the new constraints by substituting the old optimal solution and see whether they are satisfied. If they are satisfied, then just a minute. If they are satisfied, it means that the inclusion of a new constraint in the old problem would not have affected the optimal solution, and hence the old optimal solution remains optimal for the new problem also. On the other hand, if one or more of the new constraints are not satisfied by the old optimal solution, we can solve the problem without reworking the entire problem by proceeding as follows. See here, what we're supposed to understand here is, see, when we are solving a problem, or when we solved a linear programming problem with, let us take one m constraints, and that for that particular constraints we have obtained the optimal solution. Right. Now what we have to examine here is, if we add one or more inequality constraints to the optimum solution, okay, what should be its effect? Okay, so how to evaluate this? This can be evaluated the new constraints by substituting the optimum solution and see whether they are satisfied. We will just discuss how we are going to evaluate the new constraints by substituting in the old optimal solution, and what are the conditions for satisfaction, and if they are not satisfied, so what does it mean? If the inequality constraints are not satisfied when they're substituted in the old optimal solution, it means that if they are satisfied, it means that the inclusion of a new constraints in the old problem would not have affected the old optimal solution. Okay, hence we can proceed with the same old optimum solution for the new problem also. If we substitute the new constraints in the old optimal solution, and if it does not satisfies, then we no need for us to rework the entire problem by proceeding. So means no need for us to rework the entire problem, but we had to follow certain steps what they have given in the for proceeding steps. Okay. So what we supposed to do? The simplex table corresponding to the old optimum solution expresses all the basic variables in terms of non-basic ones. With this information, eliminate the basic variables from the new constraints. Okay, if the substitution of a new constraint in an optimum solution does not satisfy, no need for us to rework the entire problem. So what are the steps we supposed to follow to get this new solution is, see, the simplex table corresponding to the old optimal solution expresses all the basic variables in terms of non-basic variables, right? With this information, eliminate the basic variables from the new constraints. Then second step is transform the constraints thus obtained by multiplying throughout by -1. Add the resulting constraints to the old optimal table and introduce one artificial variable for each new constraint added. Thus, the enlarged system of equations will be in canonical form since the old basic variables were eliminated from the new constraints in the step 1. Hence, a new basis consisting of an old optimal basis plus the artificial variables in the new constraints equation will ready for available for the canonical form. Okay. Step number 4, go through the phase 1 computations to eliminate the artificial variables. Go through the phase 2 computations to find the new optimal solutions. So this is how we need to proceed if the addition of a new constraints does not satisfy the old optimal solution. So let us take the problem and we're going to solve this. Okay, the same problem what we were solving in the previous classes, same thing we're going to take it out, and we will going to discuss the addition of new constraints, how it will going to affect the optimal solution. Okay, so please make a note of this. If each of the products, example, it is the problem for adding a new constraints to the LP problem. If each of the product A, B, C, D require respectively 2, 5, 3, and 4 minutes of time per unit on grinding machine, in addition to the operation specified, find the new optimum solution. Assuming that the total time available on grinding machine per day is 600 minutes, and all this time has to be utilized fully. Okay, so what he's adding is, so we had two constraints over there. One is the constraints in the form of the lathe and the milling machine. Am I right? So now what he's adding is, he's adding another one machine. So means another one operation, which is a grinding operation, which can be performed on a grinding machine. So you will add another one constraint in the form of the time required for each product to undergo a grinding. Okay, so this is, I'll add another one constraint for us. And for this, we had to find the new optimum solution. And also they have specified what is the total time in grinding machines per day. The available total time of grinding machines per day is 600 minutes. This is how they have given. Okay, so previously we had only two machines, lathe and milling. Now they are adding another one machine called a grinding machine, and the time that each product has to undergo per unit is given as 2 minutes, 5 minutes, 3 minutes, and 4 minutes for A, B, C, and D products respectively. Okay, and also what is the total time available? on the grinding machines per day is given as 600 minutes. This is what they have given to us. Now, what we have to do here is, so in the similar way, how we used to do it or how to write. Sorry. We were writing the constraint equation in the previous classes. In the similar way, we will going to write the constraint over here. So what we do, the present data corresponds to the addition of a constraint which can be stated as, so it is 2x1 plus 5x2 plus 3x3 plus 4x4, which should be equal to 600 in the sense, so it is 2 minutes for each product. There are x1 is the number of products A manufactured per day, x2 similarly, and x3 and x4 are the number of products of A, B, C, D manufactured per day. So now, if they are multiplied by their corresponding time per unit, okay, and if we add all for all the 4 products, so that will be equated for the total time available of the grinding machines per day. So this is what we have written over here. 2x1 plus 5x2 plus 3x3 plus 4x4 is equal to 600. Okay. So now what we do here is, we substitute the original optimum solution. So we have the basic variables here, okay, and of course non-basic variables also. So from the previous old optimum solution, so the basic variables are x2 and x3, whereas x1 and x4 are the non-basic variables. Now what we do here is, for the values of x2 and x3, the optimum solution what we arrived at the end, so where the x2 value is 40 by 3 and x3 value is 800 by 3, whereas these are the 2 basic variables what we have got at the final pivot operation, right? And x1 and x4, and of course 2 slack variables xy and x6, they are not in the table, so we will going to put that as a 0. So we will going to consider that as a non-basic variables, right? So now, as per the proceedings what they have stated in the previous slide, so what we have to do here is, we have to substitute the values of the basic variable and non-basic variables in this constraint equation now. So the values, in the sense, the values of the basic variables what we arrived at are what we obtained for the old optimal solution. See, for the old optimum solution, the value of x2 was 40 by 3 and x3 is 800 by 3, whereas x1 and x4 values are zeros. Now substitute these x2, x3, x1, x4 in the above constraint equation E1 and just check whether that is equal to, okay, so equal to 600 or not. If it is 600 is equal, then nothing to be done. So directly we can say the same solution can be used, optimum solution, old solution can be used for the new constraint also. If it is not satisfied, okay, then we have to proceed according to the statement what they have given there. So now look at here, when we substitute x1 as 0, x2 as 40 by 3 and x3 as 800 by 3 and x4 as 0, so what we will going to get it is 2600 by 3. 2600 by 3 is not equal to 600. Thus, the new constraint is not satisfied by the original optimum solution. Hence, we proceed as follows. So please remember this. So if this is equal to 600 means, then you can stop the solution here, stating that so the inclusion of a new constraint will also result in the same optimum solution, and hence we can retain the same optimum solution for the new constraints also. Okay, since in this case it is not satisfied, okay, so then we have to proceed with the following steps. So how we will go to proceed, we will just check it out. From the original optimum table, we can express the basic variable as x3 is equal to 800 by 3 minus 5x1 minus 7 by 3 x3 minus 4 by 15 x5 plus 1 by 15 x6. Okay. So original table, you go there, and original optimum table, loss table, what we have arrived. Just a minute. Yeah. So now, from the original optimum table, what we have got, the loss table in the previous uh, optimum solution, what we arrived. So from that, we are writing, we are expressing the basic variables as x3 as 800 by 3 minus 5 by x1 minus 7 by 3 x4 minus 4 by 15 x5 plus 1 by 15 x6. In the similar way, we are expressing x2 also, x2 as 40 by 3 minus 1 by 30 x1 plus 1 by 30 x4 plus 1 by 50 x5 minus 1 by 15 x6. So this is how we have expressed the basic variables from the lost, that is optimum table. Please remember that. Okay. So now, does the equation E1? So equation E1 is there now, that we will going to express in this way now. So we will going to write it as 2x1 plus. So x2 is 40 by 3, 5 times this, the same expression. x3 as 3 into this, and plus 4x4 is equal to 600. Got it? So now we will going to get the E2. E2 in the sense we are getting the constraints only in the form of non-basic variables. See, look at here, non-basic, all these x1, x4, x5 and x6 are non-basic variables. So what we are doing here is we are expressing the basic variables in terms of non-basic variables from the lost optimum table, and we are substituting those x3 and x2 in the new constraint equation, so that the new constraint equation can be obtained only in terms of the non-basic variables. So when you look at this equation E2 here, so look at that. So minus 19 by 6 x1 minus 17 by 6 x4. So all are in terms of non-basic variables, okay, which is equal to 800 by 3. This is a step 1. Next, step 2, what they say, transform this constraint such that the right hand side becomes positive. That is, look at here, right hand side should be positive. So we have got minus 800 by 3. So now we are getting this as, we have to make the right hand side positive. So just multiplying with the negative sign over here. So here we have got 19 by 6x1 plus 17 by 6x4 plus 23 by 30x5 minus 1 by 15x6 is equal to 800 by 3. Got it? Yes. Now what we do, add an artificial variable xk. Okay, step 3. The new constraint given by the equation E3 and the infeasibility form Wx4 in the original optimum table to obtain the new canonical system. So it's the same thing what we have got there. So artificial variable is adding xk. xk is adding it as an artificial. The x3 and x2 will remain same. No changes with the x3 and x2 here. Okay, so x3 and x2 will be the same table what we have got in the last optimum solution table, that will remain same. But in the step 3, what they say is they are adding a new variable, that is artificial variable equals such as in the under the column of basic variables. So xk corresponds to the new artificial variable, the new constraint given by the equation E3, and infeasibility form W, which is equal to xk in the original optimum table to obtain the new canonical system. Okay, so we are adding one artificial variable, a new constraint, and an infeasibility form W, which is equal to xk. So in the original optimum table, and this is the new canonical system what we are getting. So following, my dear students, if you have any clarification, you can stop me. Mithun, Danush, Sukrut.
Yes,
If you're
sir.
following, please make a note
Yes,
of
sir.
this because
Yes, sir.
this has been once asked in your examination for 20 marks. That's what I'm very much worried about this lost when adding a new constraint to this. Okay, so please try to write it down. Want to make a note of this, how the procedure is been following here. Okay, what are the steps and how we can do. So once you do it in your book or a paper, then you will have a clear picture how we can get the solutions. Okay, please practice. Please keep on writing once as we just keep on explaining these things in your systems, right? So if you have any clarification, you can stop me. We will go discuss it. All right. So I think there will be no doubt till now. Any clarification, anybody?
No, sir.
Shall I
No, sir.
continue? Shall
No,
I
sir.
continue?
Yes, sir.
All right. So now
Yes, sir.
what we have done in the step 3 is we have added an artificial variable xk. Okay. So now, so look at this table here. Just look at the table and the element values also here. So x3 and x2, they will have the same values, no change. Of course, in the artificial variable point, you can put it as 0. You can put it as 0 here, right? So, of course, under the W column also, you can put it as 0 for x3 and x2 columns, x2 rows. Okay. Now, what we're supposed to do here is xk. So we are adding a new element over here. It is called xk. So that xk, we need to put it for the another one row along with the basic variable. So what we are putting here is, so 19 by 6, the same what we have got in E3, 19 by 6. Okay. Then here we have 0, x3 also 0, x4 is 17 by 6. Here we have 23 by 30, x5 minus 1 by 50. This is for the x6. And we have an xk. So here you have to put 1 and remaining is 0. And here bi is 800 by 3. What we have got is 800 by 3. Okay. So now what you have to do, you have to do the pivot operation here. So what we have done here is, it is, this values also remain same here. And W will become minus 19 by 6. Rest of things will be 0. So rest of things will be negative. So similarly, how we have got the cost coefficients, the W will also taken as the infeasibility form. Infeasibility form, in a similarly we have 19 xk values. So we have put everything W as a negative of xk. So minus 19 by 6, 0, 0, minus 17 by 6, 23, minus 23 by 3, minus it was now 1 by 15, and it is minus 800 by 3. So now when we look at here, so since it's a negative form, so we have to consider this as a negative, minimum negative along the lowest column, lowest row. So here we are going to consider this as the negative minus 19, and this will become the pivot column. Am I right? So with respect to this pivot column, once you get, then we can get the ratio of BI by AIS. So how do you get BI? BI is 800 by 3 and AIS is the element across the pivot column. So 5 by 3. So 800 by 3 divided by 5 by 3. So you're going to get 160. Similarly, 40 by 3 divided by 1 by 30, we're going to get 400. 19 by 6, sorry, 800 by 3 divided by 19 by 6, you're going to get 1600 divided by 19. So out of this, which one would be considered as the maximum minimum? Positive minimum here. Positive minimum will be 1600 by 90. So now this will form, x4 will forms the a pivot row. So once we get a pivot row and this is a pivot column, so this 19 by 6 will become the pivot element. Okay, pivot element. Please look at this. Pivot element 19 by 6 will be the pivot element. Now finally what we have to do now in this case, how to remove the artificial variable. How to remove the artificial variable. So why? Because here xk will leaves the basis and x1 will enters the basis. Am I right? So x1 enters the basis where xk leaves the basis. So based on that, now we have to apply the pivot operation here. So once we apply the pivot operation, so what we will going to do here? So look at here. After getting the pivot operation, so you will going to get this way. Yeah, please do this. I want everybody to solve this. So how we have done the pivot operation, in the similar way you have to do the pivot operation here. Same procedure how we discuss, the same thing you will go to get it. x1 enters, xk leaves the basis. x1 enters, xk leaves the basis. Please do this. I will give another roughly 4 time minutes time for people. So please complete this. How you get this? Can you get this if values correctly? Yeah. Were you able to get those values, my dear students?
Yes, sir.
Okay. You have to do the pivot operation there, and you have to get these values. Yeah. So after the pivot operation, so if we get these values here, look at here. So finally, what we are going to get, x1 as 1600 by 90, x2 as 200 by 90, and x3 as 2400 by 90. So these will form the basic variables for us, and the x4, x5, x6 will become the non-basic variables. Okay, so therefore the profit, what we are going to get, the first coefficient or first value will be minus 1,64,900. So 64,000 divided by 90, and the profit will be 1,64,000 by 90. This is a new optimum solution what we have obtained for this problem. Okay, so only thing you should be very careful is in this procedure you had to add one artificial variable, okay, and one invisibility form also. Once you add artificial, another invisibility form will come into the picture. So adding that, and you will go to get the use the pivot operation, and then finally you will go to get. So ultimately you have to check it out. The values under that F and W column should be a non-negative number. It should be a 0 or non-negative number that should be there. Be careful. Okay, so once you get, then you can stop the pivot operation. If you find any one of these values as a negative number, then again you have to proceed with the pivot operation. Got it, my dear students? So this is the final, the next, the new optimal solution what we have got it for the changing or adding a new constraint to the personal LP. Yeah. Any doubts, any clarification for anybody we can discuss here? Because this completes the sensitivity analysis part. So maybe we have taken more than 4 or 5 classes for this program, but not an issue because it works for a one full question for 20 marks. Yeah. Any doubts, any clarification, my dear students, we can have a discussion.
No, sir.
Then Dhanush could or be able to follow, could you are just practicing these things in your home. Because
Yes, sir.
most probably exams will be there. I think even though you have last working day, maybe 7th of July, I don't know whether we do just planning to have an examination. So be careful, please don't take it very lightly. Okay, because many of the students, almost 3 or 4 students, they are become very irregular to the class. I don't know why, especially Srinidhi, Paul. Where they have got any idea?
Sir,
No, sir.
Srinidhi has gone for Hyderabad, sir.
Okay. So this is the time for that.
But I don't understand more.
Sorry? Vidhu?
About Sandesh Mohana, sir.
No, what is the wrong with those people? Because these are all very important things we should attend. Being entered students, when miss the classes like this, you have to find it very difficult. It is a theory part, not an issue. But when you are discussing a problematic, so plenty of things needs to be understand. You need to get practice. Until unless we practice, possibilities of making mistakes will be more. Then ultimately they will start losing the marks. They're not still UG students, they're all PG students. The importance of the class, each and every class. Okay, whatever it might be. So people attending, so please practice this. Okay, so get in touch with the textbooks or whatever the notes I have just uploaded in the Google Classroom. So please start practicing all those things. It will be easy for you people to get the final values in the loss in the examination. Okay. So I
Yes,
think
sir.
you might be having the third internals also. So third internals definitely I'm going to add module 3 for complete solutions and problems, everything what we have. Okay. So I think tomorrow I will be posting your the seminar schedule. Okay. So please get prepared, get download the material, and the presentation is for 15 minutes. So one class I need to have 3 students to be done on one class. So maybe 2 days it will take for me to complete the presentation. So please inform your friends also regarding this. For those who are out of station and they are not coming to the class, it is mandatory because it carries 5 marks in your 5 to 10 marks for your info assessments. Okay, so no other presentations will be done. So please inform your friends and ask them to get ready with the presentation. I will be posting the schedule by tomorrow. Okay. Okay, so we'll meet on Monday. Okay. So please practice these problems, and I will be posting another one assignment by shortly after your presentation. I want to have another one assignment. So please practice all these 3 problems. If you have textbooks, please take an exercise problem and try to solve of your. Okay. Thank you very much. We will meet on Monday.
Sir,
Yeah. Anything?
sir, seminar presentation we'll do on Monday, sir.
No. Monday you have. No, I don't have Monday. Monday I told you I will have it on Wednesday and Thursday.
No, sir,
Yeah.
I said that we'll do on 15th and 16th.
15th and
15th and 16th, sir.
15th I will not be available. Yeah, that's a problem. 15th and 16th means. So next Monday and Tuesday. Yeah. Why?
Sir, because this Monday one seminar is there, sir. Ganesh sir seminar is there, and Friday we have a technical seminar, sir. We need to do prepare report as well as PPT for that, sir.
Friday you are having a technical seminar. Huh?
Technical seminar, sir, which is given by Kiran, sir.
Okay, so we will do then one thing. We will have it on 17th and 18th.
Yes, sir.
Yes, sir.
15th most probably I will not be there. Maybe 17th and 18th we will have them. Get prepared. Okay.
Yes, sir.
Okay. Thank you.
Thank you, sir.
Thank you.
Thank you so much, sir.